Hello everyone. Today we will discuss the phenomena of capillarity. Now what is a capillary? Capillary is a tube of very small cross section area, and capillarity is the study of the rise or fall of a liquid in a capillary. Now this I have already written to save some time. Now we have some applications. We always use towel. Towel works on this capillary action. The small pores in the towel act as capillaries. Oil rises in the wick of the lamp due to the capillary action only. Blotting paper also works on this. The very small pores in the blotting paper act as capillaries. Ascent of sap, or you can say the rise of nutrients in the trees, takes place by the capillary action only. Then there is one more application. We can preserve moisture in the soil by ploughing, because by ploughing the capillaries are broken down and we can prevent the moisture from rising up and getting evaporated. Now we have to discuss the capillary formula or the Ascent formula, right? So for that, let's consider that we take some liquid in a beaker, and at the instant when we place the tube of very small cross section area in the capillary, at that instant the level of the liquid will be here only as the level in the beaker, level of the liquid in the beaker. So according to the concepts which we have already studied, the pressure at A must be equal to pressure at C, must be equal to, if C and D are at an equivalent level, then pressure at D must also be same, and this must also be same as pressure at B, because A and B are also at nearly the same level. Must be equal to pressure at B, and pressure at A and C is actually what? This is P atmosphere, atmospheric pressure, right? So but we know that pressure at A and B is not same. We have studied that pressure on concave side is greater than pressure on the convex side. So that means if we talk about pressure at A and pressure at B, the pressure at A minus pressure at B is equal to 2 times the surface tension upon the radius of the meniscus, where R is equal to radius of meniscus, right? So that's why the pressure at B cannot be equal to atmospheric pressure if we consider this as equation 1, and from this equation 1 we can write that pressure at B is actually pressure at A minus 2S upon R. Pressure at A is how much? Atmospheric pressure. So you can write that pressure at B is atmospheric pressure minus 2S upon R. If I mark this as equation 2, from 2, pressure at A is equal to atmospheric pressure, right? So that's why the pressure at B is something subtracted from atmospheric pressure. That means pressure at B is not same as pressure at A, pressure at C and pressure at D. That is not the equilibrium condition then. So to attain equilibrium, what happens is that the liquid rises in the capillary. So this is unstable. If I mark this as diagram 1 and this as diagram 2. So we can say that diagram 1 is unstable since pressure at B is not equal to pressure at A is equal to pressure at C is equal to pressure at D is equal to atmospheric pressure. Right? So therefore, liquid rises in the capillary to attain equilibrium. Now when it rises, if we look at this diagram 2, so in diagram 2, now B point rises here. Now which point is at the same level? Point E. So I can mention it now. Point E is at the same level as C and D. And pressure at point E E. How can we calculate that? Pressure at point E is equal to pressure at point B, right? So you can say pressure at point B plus the excess pressure due to this depth of point E. So here you can write that pressure at point E is equal to pressure at point B plus pressure due to depth H. Now if rho is the density of the liquid, if rho is the density of the liquid, then we can write that pressure at E is equal to pressure at B plus H rho G, right? And what is pressure at B? If I mark this as equation 3 and this as equation 4. So from 3 and 4, pressure at E is equal to P atmosphere minus 2s upon R plus H rho G. Now again, point E is at same level as C and D. So pressure at E must also be atmospheric pressure as it is at the same level. So, but pressure at E is equal to PE, and this is actually atmospheric pressure. Why? I am writing the reason. As E is at same level as C and D. Therefore, PE is equal to PC is equal to PD is equal to P atmosphere. So, if I mark this as equation 5, so from 5, in 6, if I am marking this as 6, so this will be P atmosphere is equal to P atmosphere minus 2S upon R plus H rho G. So this gives me H rho G is equal to 2S upon R, right? This all I have explained in detail just to make the concept clear. Otherwise, in some books, simply one line is written that liquid rises in the capillary to equate the pressure difference between the 2 points at the same level within the capillary and outside the capillary, right? So we can write that also in short later on, but first let me derive this. So from here I can write that surface tension R H rho G upon 2. So this is one formula which we are concerned about is this is equation 7. This is important formula. Now to convert it into the other form, we can enlarge a part of this diagram. We can enlarge this part of the diagram. So this part I am enlarging here. So I am drawing this capillary. And then I am drawing the meniscus of the capillary. And suppose this is the radius of the capillary, radius of the meniscus. This is the radius of the meniscus, and let's take the radius of the capillary. This radius is small a. You have studied about the angle of contact. Angle of contact is the angle between the tangent to the liquid surface at the point of contact. This is the point of contact. This is a tangent and a line parallel to the surface of the container inside the liquid. So this is the angle of contact. So angle between two lines is equal to angle between their perpendiculars. This line is vertical, this is horizontal. So if I consider this is perpendicular to this line. If this is the tangent, this is the radius. So this line is perpendicular to this tangent. So the angle between these two will also be theta. So if I mark this triangle O M N, in this triangle I can find the value of cos theta. Cos theta is base upon hypotenuse. This is base upon hypotenuse. So from here R comes out to be A upon cos theta. So we can write this value from equation 8. Let me mark it. From 8 in 7. What will I get? I'll get S is equal to, for R I am writing A upon cos theta, H rho G upon 2. So the formula becomes AH rho G upon 2 cos theta. This is the surface tension. Right? So this Ascent formula, this is the Ascent formula, and this gives rise to a relation between the radius of the tube, or you can say the capillary, and the height of the liquid. So this is 9. 8 and 9 are Ascent formula. 7 and 9. So this was all about Ascent formula. I need to discuss some cases also. So first you look at the complete board, and then I am rubbing a part of this board to discuss the cases. So the cases, first is, if you look at equation 7, height of the meniscus, height of the liquid and the radius of the meniscus, this product is constant if density at a particular temperature is constant, surface tension at a particular temperature is constant, G is constant at a place. So you can say if surface tension, density and G are constant, that is at constant temperature. What does that mean? A question is often asked, if we take a capillary of insufficient height, what will happen? Will the liquid fall out of the capillary or not? So the answer is no, the liquid will not fall out of the capillary tube if it is of insufficient height, because if height is less due to insufficient height of the tube, then the radius of the meniscus will increase to adjust that liquid in the same height. So I will just mention it. Better to write capillary. If capillary is of insufficient height, the radius of meniscus increases to accommodate the liquid. It will not fall out. What does that mean? I'll just draw a diagram over here. If this is the meniscus, if the height is insufficient, then the meniscus will be more radius. This is less radius, right? So this is the first case. Second case is the relation between the cross section and the height of the liquid. So from equation 9, A into H is equal to constant when the density, surface tension and G are constant. Like before. That means at constant temperature only, same as before. So you can say A is proportional to this, inverse proportional to height. That means narrow capillary, more height of liquid, right? So I hope you understood. I will give you an alternate method for deriving this Ascent formula, but this was required for proper understanding. We need to mention that liquid rises in capillary to equate the pressure on the points at same level inside the capillary and outside the capillary. Right? And then we can write that 2S upon R. This was the excess pressure on the concave side. So this excess pressure on concave side is equal to H rho G. So here I can write excess pressure on concave side is equal to pressure at a point at depth H. So this was all about the rise of liquid in a capillary. Now we need to recall here that non-wetting liquids, these fall in a capillary. Why do those liquids fall in the capillary? We need to discuss that also over here. So I'm just rubbing the right side of the board. Here rest of the steps are same. I just gave you an idea. We can directly write this also. So for non-wetting liquids, what is the case with non-wetting liquids? We know that the angle of contact is obtuse for non-wetting liquids. So angle of contact is obtuse. Therefore, cos theta is negative. So, from equation 9, H comes out to be negative. That means the liquid falls. Non-wetting liquid falls in a capillary. For example, mercury. So this is what I wanted to discuss regarding capillarity. I hope you understood the topic. That's all for now. Have a nice day.